Hi there. I haven't had time to record a brain teaser in a while, but this week on my channel, there was a hot debate about whether completing the square is worth the time. Because everyone protested, oh, but completing the square is just the quadratic formula. They are the same thing. And that made me think, well, wouldn't it be fun to actually apply completing the square to a standard equation, ax squared plus bx plus c, and show how we end up with the quadratic formula. So to the whiteboard. So there's a quadratic written in standard form, and since the quadratic equation is meant to solve the equation, I'm saying equals 0. So what I'm going to do next is a technique called completing the square. If you haven't watched the video, check this out and then come on back. But our first step is that this x squared needs to be what I call bold. It has a coefficient of 1. So the first thing I'm going to do is divide every term by a, and that looks like this. So our x squared term now has a coefficient of just 1. 0 absorbs that a because 0 divided by anything remains 0, and these other terms changed. Okay, the next thing I'm going to do is I'm going to get rid of this. I'm going to move it over to the other side of the equation by subtracting it from both sides. So that looks like this. All right, now this is where completing the square comes into play. To complete the square, and again, if you haven't watched the video, go click here. I take this term here, I divide it in half, that's b over 2a, then I square it, which turns into, and I add that to both sides of my equation. Whatever I do to one side, I have to do to the other. So my new equation looks like this. All right, now, the whole reason I did all of that, dividing this middle term in half, squaring it, and adding it to both sides, is I have now made this a perfect square. And so I may rewrite it like this: x plus b over 2a squared. If you don't believe me that this is the same as this, first take a look at my video on foiling and go ahead and FOIL this out and show yourself that you end up with that. Now on this side of the equation, I don't like leading terms to have negatives, so I'm going to rewrite these two terms. And now I might as well combine them and make them have the same denominator. So to turn this denominator a into this denominator 4a squared so that I may make good on this subtraction, I have to multiply top and bottom by what's missing. That would be a 4a. And when I do that multiplication, I get, and anybody who's familiar with the quadratic equation should be getting excited now because we've got our b squared minus 4ac. So we're going to go ahead and do that subtraction to write that all over one denominator. Okay. Next step in solving for x is we need to get rid of this squared. How do we get rid of a squared? We square root both sides. That leaves us with, this is where the plus or minus comes into the formula. When we square root both sides, we get a plus or minus over on this side. All right, now we have square rooted the top and the bottom. I can separate those, and that looks like this. And the square root of 4a squared is just, and now this is looking really familiar. All right, my last step is I'm going to swing this around to the other side of the formula. It's connected by addition. I'm going to move it through reverse operation of subtraction. And now I have one term over 2a plus or minus another term over 2a. The denominator is the same, so I can rewrite that whole thing over that same denominator, leaving me with, drumroll please, negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is the quadratic formula derived from our standard equation using the method of completing the square. Thank you so much for everyone who wrote in, because this was awfully fun. And if you are a factoring geek, I started a new playlist where I collected all of my factoring videos. So it's got the box method, the X method, difference of squares, difference and sum of cubes, completing the square, quadratic equation. Go check it out. It's a lot of fun. So keep on mathing.